Hello, Matt G for IYT here, and today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 14, which reads, a transformer cannot be used to A. Produce a greater power output in the secondary winding than the power fed into the primary winding, B. Provide electrical isolation between the primary winding and the secondary winding or windings, C. Produce a different voltage across any of its secondary windings from that fed across the primary winding, or D. Match the impedance of a load to the output impedance of a device that is used to power the load. Well, let's start by just drawing a simple transformer, and then we can look at some of its properties. So we've got our primary winding here on the left hand side, we've got our secondary winding looking slightly scruffier on the right hand side, and the transformer works by you feed something in on the primary coil, it's going to be sharing a magnetic field with the secondary coil here, and whatever is fed into the primary will be reflected, possibly even transformed, and end up being output on the secondary coil. Of course, it needs to be like an AC voltage or signal, because this primary coil is generating a magnetic field, and that's fine, but in order to induce a voltage and to transfer that over to the secondary, it needs to be a changing magnetic field which is influencing the secondary coil. So it has to be using AC or some kind of signal. And we can immediately see that this coil is not directly connected to this coil. So there is a level of electrical isolation here between these two coils. There is nothing directly connecting them, and DC will not pass through here. And we're looking for things that transformer cannot be used to, and it can be used to provide electrical isolation. So we're going to strike out on option B. So another property of transformers is that we can vary the number of turns. We could, for instance, have 5 turns on our primary coil, and imagine we just had 1 turn on our secondary coil, and that would allow us to use it to transform various properties. Let's take a look at the full license manual, and it tells us, I've got these already highlighted, brilliant. It tells us that the secondary voltage in our transformer is a function of the primary voltage and a ratio of the number of secondary turns to the number of primary turns. So if we, for instance, had 1 turn on our secondary coil, let's not do that. If we had 1 turn on our secondary coil and 5 turns on our primary coil, we would then have a ratio of 1 to 5. We put 10 volts AC in, 10 times 1 divided by 5 will give us 2 volts on our secondary coil. So we're using it there to transform the voltage across the primary into a different voltage on the secondary winding, and that is exactly what option C is explaining. Produce a different voltage across any of its secondary windings from that fed across the primary winding. Again, we're looking for things that a transformer cannot do, so we have to remove option C. So let's take a look at option D. Well, you probably already saw it highlighted actually, but we could do the same transformation with impedance as we do with voltage. Now, the formula is a little bit more complicated because impedances tend to be a little bit more challenging to deal with, but again, we see that the output impedance is a function of the ratio of the number of primary turns to secondary turns, and we actually square that ratio and multiply it by the output impedance to get our input impedance. And of course, like with the other ones, you can rearrange that and use that ratio to figure out the output impedance based on the input impedance, for example. So we can match the impedance of a load to the output impedance of a device that is used to power the load. In the same way we can do a voltage transformation, we can do an impedance transformation as well. So we've got to remove option D, and that leaves us with just option A, which has to be the right answer. But why is it the right answer? Well, there's an interesting word here. We've talked about transforming voltage, we've talked about transforming impedance, but option A is talking about producing a greater power, transforming the amount of power. Now, it doesn't matter if I'm transforming the voltage, multiplying it 1,000 times, I'm still only getting the same amount of power out. And of course, we know from Joule's law that the power is a function of power equals current times voltage. So if the voltage goes up, the current has to go down. So if we transform, in our example where we transformed the primary voltage from 10 volts to 2 volts by a factor of 5, so the voltage went down by a factor of 5, but the amount of current we could pull out this secondary coil went up by a factor of 5, in theory. You're at the maximum amount of power that you will ever get out of a transformer is the amount of power that you put in. And in reality, there is going to be some resistance to this wire, so the power that's being input, some of it's going to be lost at heat. Not all of it is necessarily going to be captured in the secondary, so there's going to be some losses there. And there's also going to be some resistance in this wire, so some of the power on the secondary coil is going to be lost as heat as well. But you're certainly never going to get greater power out on the secondary winding than the power fed into the primary winding. That's not the same as with the voltage or the current or the impedance, because you're trading that off for something else. So the answer here is A. Let's skip down to the answer key and see if we've got that right, and we see that, of course, for question 14 the answer is A. Thank you very much. I'll see you for the next one.